Let's put mic on. Thank you so much. So as I said, I'm really impressed with your determination to this particular topic, and I hope the information that you will learn will actually help you in your day-to-day life. I'm Nellie Porter. I'm Principal Lead Program Manager with Windows Client, part of Windows Client called Windows Core. And in my security team, my expertise, and because I'm program manager, we called about ownership, is actually about the coolest areas in security. It's holy grail of security. I'm owning crypto, I'm owning PKI, and I'm owning also the whole entire modern authentication space. And when we're talking about modern authentication, we're not talking about passwords. We're talking about strong authentications that we believe our users deserve to have. So it's me. And I will walk you through interesting, I hope, presentation. And because it's not too many of us, please interrupt me anytime. Please ask your question. You don't need to wait for Q&A, but whatever you have in mind, I hope, related to the session, please speak up. Okay? So let's start. Today, I will talk about 3 topics. And despite the fact that they look slightly unrelated, they're all related to each other. First, we will talk about biometrics. And biometrics, what we've done with Windows 8.1 around these very convenient user authentication methods. The second one, what I will cover today, is going to be about TPM key attestation. So despite the very complicated name, we will talk about device authentication, and mostly for your new BYOD devices that you need to trust. When your user is coming to your enterprise from those devices, you need to ensure that you have your trust anchor that you can validate cryptographically. It's the second topic of my discussion. And the third one is a strong user authentication, and what we've done with virtual smart cards and what we added in Windows 8.1. Okay, so everybody, when they're talking about security, started with this slide. And passwords are evil, and everyone hates them. I don't think there is one person, I'm not talking about in the room, but in the world, that actually likes them. Passwords for human beings, I'm not talking about you, but normal human beings, is trouble. Because they need to remember those very strong, very complex passwords. Have you tried to type on touch screens those complex passwords? It's actually taking approximately 10 times more than using keyboard, or even 15 times more. So passwords becoming inconvenient, impossible to remember, and actually they have very serious flaws from a security standpoint. So what is that? And you heard all of that. So passwords have minimum 3 problems. They easily phishable. It means our users are so used to type the passwords on anything that looks like sign-in page. It smells like sign-in page. So they will go and type the password without any problems, and their identity can be easily phishable. The second problem that you're probably well aware, passwords are symmetrical secrets, and it's very easily replayable. So as soon as I have your password, then I can play it in anywhere on my bots there in China and authenticate myself against your enterprises. And again, when we're talking about secrets, passwords are symmetrical secrets. It means I know my secret and you know my secrets. What's the secret is that? Have you seen secrets that everybody knows? So password is really, really problematic. And because users are trying to reuse the same passwords again and again, they can't remember 16-character passwords with letters, uppercase, lowercase, numbers, and all these not printable characters, it's almost impossible to protect your enterprises because your protection, your security is equal of those absolutely throwaway accounts of the websites that user typing the same, absolutely the same domain, username and passwords, not maybe username, but passwords absolutely. And then your protection and those throwaway websites protection is equal. Everybody on security talks. I love to show you some very scary, very horrifying quotes. I'm the same, I love quotes, but again, I will try to do it very quickly. So the first one, it's actually, and everything is 2013, and everybody who reads know everything exactly the same as me, that passwords are absolutely outdated and problematic. So Facebook, 9.8 million adult users. Somebody that are not authorized access their account. They were humiliated online, defrauded, and their actually life was quite difficult after that. Deloitte in 2013 published a very interesting study. What they've done, they investigated 6 million user-generated accounts. And what they found that out of those 6 million, 10,000 of very common user passwords that you can find online very easily were used for 98.1 transactions. So it's not only that our users reuse the same passwords, they reuse the most common passwords. And the last thing, all these troubles that I'm talking about, it's not only big enterprise guys are suffering from this problem. In UK alone, small businesses were attacked by intruders. And the number is growing every year. And again, enterprises already in so bad shape that the growth is not as, again, evident, but small and medium guys are attacked exactly the same. So the question is what we do about that. We can talk about our problems, but do we have any proposals or solutions for you? And the first proposal and idea that we come up with, if we want to move users from passwords, we need to make it so convenient. It needs to be so user-friendly. They don't need to sweat to remember the things. Or they don't need to do all these horrifying things to authenticate themselves. It needs to be incredibly convenient, easy, and they don't need to remember anything. So what can be better than biometrics? We investigated every single biometric trait, from face recognition, voice recognition, your, again, typing patterns, everything. But what we realized very quickly is that to make authentication work, the only solid technology on the market today is fingerprints. There is nothing like that. And the reason why, because you want to protect those machines and this access from intruder, and it means false acceptance rate should be low. And you want to allow legit users to log in, and it means false reject rate needs to be low. And it's only and only technology today that can satisfy our very high security requirements. So let's go to some things that we're familiar. We're familiar that users type those things on the screens or with their keyboards, and some things that we believe modern and coming is fingerprint. For my team, and we own this functionality end-to-end, the main 4 goals we have in mind. We need to ease the struggle of users to type those long, complicated passwords on their touch screens. We also want that all experience will be absolutely built into Windows. So users will not have different experience when they trying to enroll with fingerprints or trying to use them or trying to utilize whatever you have with different application. We want to have consistent, easy to understand experience end-to-end. The third big requirement that I had is we want to move away from swipe sensors. I don't know how many of you even tried swipe sensors in your life. Thank you. So the point that I'm trying to make, swipe sensors are not intuitive. They're not user-friendly. You need to swipe your finger not too low, not too fast, not too slow, not to the right, not to the left. So your swipe sensor would be able to capture the stripes and compose the image to do the template creation. So for users, they need to work with this tag instead of the tag will work for them. So we had to change this situation. And swipe sensors still exist. They still will be present on your Lenovo and Dell and HP sensors, laptops and tablets, but we're driving really seriously all our efforts to go with touch sensors. And there are multiple reasons for that, and we will talk about that. And the last thing, we want to light up a few very engaging scenarios, because it's usually touch sensors more expensive than swipe sensors. And to promote them through OEMs and our ODMs and our IHVs, we need to ensure that we have the value for them and for all our users. And I will show you all those really cool scenarios that we enabled, and I hope you will understand what we've done. So when we come up with the idea, usually we test it with our users. So we have user groups. And surprisingly enough, none of them, or almost none of them, actually know anything about biometrics. And the feedback was very positive. They've seen that as really a solution for their passwords. They don't need to remember their passwords. They always have it with them. And the second point that we received from those user studies, when our users were introduced to this technology, they actually believe that it's part of experience. It was so intuitive that they don't need to interrupt what they want to do. And again, it's not like UAC when you have no idea what you consent to. Here it's very clear what they're trying to do and what they consent to, and you will see it in my demo. So let's move to demos. And we will have a lot of demos here. So first of all, before I will go with demos, I don't know how many of you have seen our new sensor. And this sensor is a touch sensor, and a lot of confusion with this touch sensor, despite the fact that it's attached to a big USB cable. The idea is that silicon of this sensor will be on board of your laptops and slates and tablets. It's not going to be hanging out of your USB port. It's not going to be convenient. It's not going to be pretty. It's not going to be usable if it would be like that. So this sensor is actually produced by fingerprint cards, and we have a few guys in the room as well. And it's probably our first runners with this technology, and we have more people working on this technology as we speak. So we will introduce them as soon as they will be ready. Okay, so let's switch to demo. And the first demo that I will do, let me try it as soon as I will be back. Okay, let's go to very basic scenario. So I have on this machine 2 accounts. And I don't know how many of you, but I experience it every single time. I have kids at home. And surprisingly enough, my kids, they know my password very well. And they can type on my touch screen much better than I can. And it's actually created a huge problem for me, because my kids, again, even the very intelligent kids, can expose me to some kind of trouble. They can sell my stocks. They can send email to my boss, and from this moment, I probably would not be promoted anymore. It will be all kind of access to things that I don't want my family member, even I love them, to do for me. So, and the idea is, again, I will simulate it. I have 2 fingers. One of them, it's me in my, I will not touch these things anymore. Me with my domain account. The second finger, again, whatever it is, will represent my son's account, and we can switch very easily. None of us need to remember the password. So let me show it to you. So I am logging to my account, and I'm done. So it's my domain account, and I have my apps that actually appropriate to my age and status. And I have everything that I can trust, and I know that my babies would not touch it. So, however, if I will switch back, and I will touch my sensor again, it will come to my next account. And this, again, it's me as well, but it's my Microsoft account with all kind of crazy apps that I download and have nothing to do with my enterprise for a change. Okay? So let's go one step further. So login scenario is something that all of you know very well, but let me show you what we've done in addition to that. And scenarios that I want to show you is probably not as enterprisey as you want, but it's the same thing, is about how we'll buy apps. So when I'm buying my apps, and I want to buy this app, okay, let's go with something a little more expensive to get it more interesting. Oh, $28.99. No, it's too, come on, something better. So let's go to some really fun game. Okay, and I'm trying to buy this app. So it means I want to ensure that my financial instrument is actually attached to my account, and only I can buy apps. Not my babies will start to buy all kind of tokens or all kind of things that after that I have to deal with my huge bills. So all what I need to do, I will go buy, confirm, and surprisingly enough, I need to authorize this purchase. So I need to tap sensor, and it doesn't listen to me. And I need to tap the sensor to buy this app. So I apologize, I didn't put my credit card here, so it's asking me to put it, because with all my demos, I would have $1,000 of apps on my account. But the idea, if I would have my credit card attached to a Microsoft account, I would be able to buy apps. So moving from buying apps from the store to something that every developer would be able to enjoy. So this one is an app. They're trying to add some packs to this app, and we called it in-app purchase. The same thing, you would be surprised, probably not. When I'm trying to buy anything, again, the authorization coming to the owner of credit card, not to the person that log in with this account, but to the owners that control financial instrument. Okay? So if I will go and try some third-party app, and again, the third-party app want me to buy the dinosaurs package. Okay, I'm all for that. And I will confirm price, and exactly the same as App Store itself. Every single financial operation I will do, I would need to confirm this operation with my swipe or touch. I hope it will be touch, come on. Okay, so it's the first step. But in addition to that, we believe that it's not only functionality that we have to use or can use for our first party experiences. We believe that any app, Windows RT app in particular, can utilize the same functionalities that we built. And they need to forget about asking user to sign in with their username and password, maintaining all those passwords for their apps. They can utilize what we do with biometrics. And to demonstrate it for you, I will run some things that we called Windows SDK. It's boring slightly, but it's actually SDK samples that you will receive as soon as we will announce Windows release in our build sessions. So we have two types of APIs. I don't know how many of you developers, but one of them is to check availability. And to check availability, we will check if you have bio and you have user enrollment in this bio. And again, in my case, I do have availability, so the API is actually report yes. And after that, any developer would be able to request user consent. And we were thinking about these APIs. Our goal was to provide ability for developers to, for example, we have this concept of clock. Some of the data that we don't want everybody to look at. For example, I have plenty of pictures on my phone or on my tablet, and I'm passing it to somebody to look at. Maybe not every single picture that I have on this picture roll is appropriate for everybody to look at. So would it be cool if somebody would add this consent for me to clock those inappropriate or too personal pictures? So when you are swiping through all of that, you would not see them. Or for example, there is some app that needs to deal with your financial data, taxes, something. Maybe you don't want that anybody will open this app. So those APIs would be for those folks. So let me show you what it looks like. So again, developer can specify what we can consent to, say to anything to sell my stocks. And we will request consent. And again, sorry for a look and feel of that, but everything can be changed. So it means the developer would be able to request consent for their specific application. The applicability for line of business apps we see already with our Microsoft IT organization, because they don't want that anybody would be able to access every single app. So even for their apps, they're thinking to add functionality like that to ensure that login user is actually consenting to start this app. Okay? And definitely I can consent. And user presence verifier. So we return yes, no. We never returns credentials to any developer. Okay? So one additional thing that I want to show you is, again, if I'm going to HTTPS side, and this side would require my authentication. In every place where you will go, instead of typing your passwords, you simply can authenticate and access your SSL share with your, again, the angle is trouble. And you can access the share. Right now I'm accessing our own share for, again, deployment of virtual smart card in Microsoft, but you would be able to authenticate user with Simply Swipe. Okay, so let's move on. I think we've done enough with biometric. And here it's, again, the whole idea about our APIs and what you can do with that. And we've done this demo. So switching gears a little more on a little more heavy stuff. So don't worry, we don't need cryptography books here, but we will try to go one level deeper on functionalities that we called TPM keys and certificates. So the idea is that when you have your Windows 8 device, you as admin would be able to issue certificates that actually connected or enabled or actually sealed by TPM. This functionality exists in Windows 8. And in addition to that, in Windows 2012 Active Directory Certificate Authority role, you would be able to issue a template that would request client to provide TPM-based certificate and keys. And we started with this functionality in Windows 8, and as soon as it started to be deployed, we learned a very interesting lesson. People came back to us and said, okay, great, it's, again, not exportable. You cannot anymore take those certificates and keys and move around. But how we can prove that? Client can lie. Client can have, again, malware or anything that would simulate the TPM. It will be a little more definitely intelligent malware, but it's always possible to simulate that. And even when client asks to generate those certificates with a pair of keys associated with that, it can report back that it did it, but we have no proof. The second question came very often. I don't want to trust every single TPM. My organization wants to work with specific BYOD or desktop or laptop machines, and I want to limit my trust only for those specific TPMs. What can we do for that? And it's very interesting questions, because in the world of certificates and keys, the question of proof means cryptographically verifiable proof. So to address those specific questions and requests, we come up with a solution, and this solution is called TPM key attestation. And the idea behind that, that when we enable user to prove to certificate authority, I will use it CA for short, that is actually really created on TPM, then only those users would be able to finish some trusted operation from those devices. Think about these BYOD devices that you have to deal with. You will have this trust anchor in those devices that you would be able to utilize in your policy controls as time progresses. So the idea between that is we take certificate that represent user and we bind it to TPM with cryptographically provable functionality. So to start and go one level deeper, let's talk about terminology. And it's, again, the complexity will not be as you can think. There are three types of keys or certificates that every TPM has today. Every TPM that we have today has what we call EK keys, and it's endorsement keys. Those keys are actually infused into TPM on the manufacture floor when TPM is created, manufactured. Those keys cannot be tampered or exported. However, the problem with those keys, they're unique for this machine, and they can be very easily used as GPS location for those devices. The second thing that you need to know through my session, I think it would be useful, is endorsement cert or certificate. An endorsement certificate exists on every single FTPM or TPM 2.0. TPM 1.2 has only and only endorsement keys. And the last thing that I will use during my presentation is what we call AIK, or attestation identity key. And the idea of those keys, they have ability only to sign the blob. They don't have ability to encrypt it. AK keys can encrypt, but cannot sign. AIK is used for the reason that I outlined before. EK is very unique for this machine. But derived keys, AIK keys, can actually help to hide identity of this machine. However, provide very easy derivation from EK keys. Okay, we're good on terminology? Now it's getting very simple. I have Bob, and Bob has TPM-capable machine. Okay? He's very happy. It's probably Surface or any Windows 8 certified machine. We have certificate authority. In this particular case, certificate authority that provides this functionality is our own Active Directory certificate authority, Windows 8.1 server. I need to talk about this cloud a little more. So we have three methods to validate this functionality. The first method is called on first attempt. It means users sign in with their domain credentials, and we will go through TPM attestation handshake, and we will issue TPM-capable certificates or keys for this particular user. The second one is, you remember when organizations wanted to limit TPM trust for their specific organization. We have PowerShell commandlets that can collect EK pubs, EK public portion of EK pair of keys, and again, deliver it to administrators. And then administrators can trust only in only those devices that have those specific EK public keys. And the third option, the most easy option, it's called EK cert. And with EK cert, you don't need to collect anything, because EK cert has chain to certificate authorities that you can trust. And based on that, you validate your root of trust. So in this particular example, I will go with the most heavy loaded. It's when you collect all EK pubs and put it, this functionality, those specific IDs, those keys, on your certificate authority. Okay, be with me. So client is trying to ask for cert. What it does, it submits what we call certificate request. Together with this certificate request, what client will do, and again, when it creates certificate request, it's trying to issue what we call RSA keys associated for this request. And those RSA key is created by TPM. But to prove that it's happening on TPM, we have two additional keys that we need to send back to certificate authority. We sign the blob with AAK. Again, AAK is the only one that can sign the blobs. And we add public portion of these pair of keys to this blob. We also sign everything by EK cert. EK cannot sign. So after we've done all of that, we added EK public key to this payload and send it to the certificate authority. So what certificate authority will do, they're going through the white list of those EK pubs that they trust, and they compare it to those that we send from the client, and if the match happening, they're saying, perfect, client, you have EK pubs that I trust. Let me generate a challenge for you that only and only if you have EK private key on your TPM, you would be able to decrypt my challenge. And that's what's happening. We're receiving this challenge encrypted to my EK public key. And what client is doing, it's loading this blob to their TPM. And because client is actually possess private portion of this key pair, it can decrypt this challenge. And after that, it's sending back decrypted challenge and saying, here, you have it. You have my challenge back, and I'm proving you that because I have both EK public key and EK private key that actually not possible to remove from TPM, I actually completed my RSA key creation on this particular TPM. Certificate authority is any authority, validate challenge, saying, yep, sounds like mine, and issued certificate. But it's not a regular cert. This cert has very interesting thing inside of this cert that can be manipulated because it's signed. It has what we called OID, and sorry, Microsoft always about terminology. It's object ID. Think about this policy claim. So what we doing, we adding special OID to this cert to signify the whole handshake that we went through. And it's very important because of very many use cases when this special cert will give you special privileges. Let's talk about two users, Alice and Bob. And again, Alice is happy. She has, again, TPM-capable device. And Bob, poor Bob, he's using Windows 7. Sorry, Bob, he doesn't have ability to validate his TPM cert with authority. So again, Alice, thanks God, received what she's asking for, TPM attested cert, and Bob, sorry, Bob, no. What happened after that, the radio server has policy to look in those specific OIDs that we added to the certificate. And what radio servers that will get access to your VPN connection would check this special OID and will say, yep, I can allow this user through because I know, and it's cryptographically proven, that this user is using certificates and keys that validated by certificate authority, and it's actually not tempered, not replayed. It's absolutely bounded to the device that user coming from. And so Bob, sorry Bob, he can't get through. So here I show you two different certs. One of them is my real cert. And again, it doesn't have TPM attestation here, so I'm poor Bob in this case. And the second cert, it has those three properties that actually emphasizing the fact that we went through TPM attestation for these things. So I will have walkthrough for you. In Certificate Authority Active Directory, all what you need to go to their template. And this template is V4 template. And inside of this V4 template in the properties, you would have this additional tab that you didn't have before, and it's called key attestation. And different ways of validation is actually options in this particular tab. You can validate it, not validate at all. It means issue any cert normally. Or you can actually ask to validate through EK pubs, as we discussed collecting EK pubs earlier, or through EK cert. And you also can put this magic OID in the cert, but sometimes you probably, again, don't want this particular signature in your cert. So you can, again, do not put this magic OID into cert. It's up to you. Okay, so talking about certificates, we believe that we've done a lot of work in this area. And certificates is actually something that we believe have to help us with passwords. And that's why certificates provide these asymmetrical secrets, because by authenticating user with certificates or TPM-bounded certificates, you actually achieve this wonderful thing that my secrets, my private keys, it's mine. And your secrets, your public portion of my key pair is yours, and we can very easily communicate and authenticate each other, and we use it today for very many years. So with WinRT functionality, we added a lot of additional things that developers can do to utilize certs moving forward. So we added ability to create certificate object. You didn't have it in Windows 8. You can filter certs. You can actually, with specific certificate user shared capability, add certs to my store. All of that is possible with WinRT for Windows 8.1. And the last thing that I want to mention on this topic is our new simple certificate enrollment protocol. It's called SCAP. And sorry, Chris, we're using SCAP interchangeably, but SCAP in this context, it's not system, client, endpoint protection or something like that. It's actually what everybody in the world knows. It's simple certificate enrollment protocol. This protocol exists for years, 10 years to be exact. Apple, by the way, all iOS devices and OS X, it's how they provision the certificate for their devices. Every single MDM knows how to provision it using SCAP. They didn't use it before. And the reason not because we want to be different. Sometimes different is good, but not in this particular respect. But the reason why, because all our enrollment experience was all around AD. Our protocols were AD related. And our enrollment protocols for AD provide enormous amount of functionality, like auto-enroll. You don't need to ask your user, you will do it automatically. However, SCAP will help us to enroll certificates on non-domain join devices. You remember your BYOD case? In previous world, in Windows 8, to enroll those devices were really pain. And we heard your feedback. We understood that we need to do something. And the problem with SCAP, why My team didn't look at that very seriously. There are plenty of security flaws with this protocol. This protocol was invented 10 years ago by Cisco to provide on your routers ability to issue your certificate for your printers. So we're moving that to something that it was not designed for user authentication. But in 8.1, on NDES servers that, by the way, deployed probably 90% across the world, we change our code over there to fix those security issues that we were very worried before. And starting from Windows 8.1, our client natively supports SCAP. And also, not only that, we expose SCAP APIs through OMADM for any MDM to take advantage of. So with these efforts, we believe that we will help enrollment of our BYOD devices. And when the enrollments will not be painful, certificates and keys will be used for user authentication. And it's how we want to beat passwords. And the last thing that I want to talk to you today, it's about strong user authentication. So I don't know how many of you still remember, where's these things? It's actually smart card reader. So now imagine me with these things running around because our Surface or any other tablets don't support today those things. So how you would be able to strongly authenticate users if you need this reader in your devices? So it's how we come up to Modern Vault. And Modern Vault is, let's use our devices to become a smart card. And Virtual Smart Card was born based on functionality that we had already in our devices called TPM. So TPM is actually amazing. It provides for us those three primary functionalities that we need to substitute our smart cards. Those three primary things are called non-exportability. It means everything that you save, store, create on TPM will stay on TPM, the same with physical smart card. We have isolated crypto, ability for us to do all the signing, encryption, decryption operation outside of OS boundary. It's inside of TPM. And the third one is anti-hammering. TPM provides for us ability to save user from too many times they trying to enter their PIN. Because again, as exactly with physical smart card, you have this card that you possess, this proof of possession, and you have something that user know his PIN. The same with virtual smart card, absolutely identical. The difference is this card cannot be removed. It's always there for you. The beauty of that your device, you don't need to hand this over your neck. You can continue to use your device and strongly authenticate with two-factor auth. So let me tell you something. And before I will do demo, we shipped Windows 8, but a few months before we shipped Windows 8, and it's a real story, usually when we're shipping something like that, very fundamental, we have special agreement with Microsoft IT to self-host our technology. So usually our team, again, PD team, is leading everything. We need to do support. We need to do everything, install, deploy, debug, everything of that. And we started our self-host with 100 users. And that's what MSIT allowed us to do. 2 days later, I figured out that all my 100 spaces are filled by my own execs. Because the problem is they had the surfaces, and to be able to access our corp, they need to have virtual smart card on those surfaces. The problem with that, surfaces do not support physical reader drivers. We don't have those drivers. So how you provision your highly demanding audience target customers on those services with virtual smart card. So what we invented a really cool idea, actually, is it deployed today with Microsoft IT. We using different technology called RDP to redirect your card, physical smart card, to your RDP session and use this redirected smart card to sign the request when we issue this certificate request for our virtual smart card. Why do we need to do that? And the reason why, because it's proof. It's assurance. We cannot issue two-factor auth credentials using something big like passwords. We have to use already existence two-factor auth mechanism to prove virtual smart cards. So again, the story goes, we filled our quota very quickly, and we begged MSIT to increase number of users that will use that. Very soon, we come to thousands of users. It was probably first time in my life when people were signing for virtual smart cards, and we didn't have spots. We have a waiting list for them, and they advocating for their teams and for their demos and everything, and we had no idea how we will support so many people for the technologies that we didn't ship. However, based on our great experience, by the way, right now MSIT is deploying it as production, it's not pilot anymore. And every Microsoft T, I don't know if you know, you need to be jealous, received Surface. The problem for us when we heard that Steve B told us, okay, now everybody, you have your Surface, it's like, oh my God. So now we have the whole entire company asking for virtual smart card. How we will support the entire company on our few people team. So it was interesting challenges, but we learned a lot from this pilot. We learned so much, and what we've done in our Windows 8.1 update, we actually fixed a lot of issues that we found due to these very boot camp conditions that we've been. The first thing that our execs told us, and everybody else repeated immediately after them, not because they're right, but because it's true, provisioning was not as good. But everybody had hiccups on provisioning, but as soon as you provision your virtual smart card, the usage is amazing. It's simply there for you. You don't need to do anything, and I will show you that. So provisioning, we needed to work on that. The second thing is TPM behavior. I don't know if you're aware, but different TPMs have different forgiveness. TPM 1.2, different, again, manufacturer decided that they will forgive you after you type 10 times, and after that they will increase time to hour or 2 hours or 3 hours and never forgive you. Some TPMs decided to do something shorter, and after 5 attempts, they will block you altogether. So what we realized, to have consistency, exactly as physical smart cards provide, we need to invent our software protection. And with blocking your card after 5 attempts, exactly as your physical smart card, but we do not allow you to create damage by blocking TPM itself. And the third thing that we learned, it was interesting, that whatever we will do, we need to ensure that our virtual smart cards will be absolutely integrated with multiple MDMs that provisioning those virtual smart cards in the first place. And that's really why the whole design that we went with virtual smart card, we're trying to ensure that on every surface, on every APIs, it looks, smell, quack, work exactly as physical smart card. It means every single MDM that today can manage physical smart cards can extend it to virtual smart cards. And it was the goal that we had. So let me walk you through scenarios. So demo, and this demo is actually created by my own team, and it's not final experiences. It's something that we put together very quickly. The idea of what we've done, we created WinRT APIs for those MDM companies that will provision it to provide very engaging, very easy experience for provisioning virtual smart card. Okay, so this app, we start virtual smart card. We will create virtual smart card. It will say, go next. And by the way, it will ask to authenticate. And now I will go with my PIN. One additional thing that I didn't mention, we have ability to enforce policy on that. And it's done actually through WinRT APIs. And the beauty of that you can specify the policies that you want for your company. So you don't need to have one single type of policy that you will apply to virtual smart card. Okay. The PIN, okay, do not match. Good. We check in for that as well. And again, I love to do long PIN, but you don't need to have so much long PIN. You can have 8 characters, 6 characters, because TPM anti-hammering will help you. So I will switch to my slide meantime. And the reason why I will do that, being very honest, because on this machine we have TPM 1.2. And as 1.2 machine is taking incredibly long to create virtual smart card. So you would not look on my spinning wheel anymore. So for virtual smart cards, and I will show you when it will complete. For virtual smart card, we see multiple scenarios that you can enable. So first of all, two-factor auth for your local and remote access. Client authentication or mutual auth with SSL. Very good scenario for virtual smart card. A virtual smart card redirection for your admin or any remote access through RDP will work just fine. You can use certificates that you will sign as MIME and store it on a virtual smart card. And one additional interesting scenario that we were thinking maybe you will be using, if you want to ensure that hard drive, that bit locked, is not leaving this device, you can store these BitLock keys on virtual smart card. As a result of that, those two will be inseparable. So for Windows 8.1, as I said, so it's a little bit stats. Right now we have approximately 7K people that enrolling monthly with Surfaces. We have 75K people across Microsoft that using their own Intel devices. We enable or forcing virtual smart card presence for any VPN connection and remote app access from BYD devices. It's our MSIT policy. And MS policy allow you to sign in and enroll with virtual smart card with 2 proofs. One of them, physical smart card, and second is actually incredibly painful, is you need to ask manager to approve. And it means the special code will be sent to manager will sign it back and forth, and only a few managers that check in those emails would approve your virtual smart card provisioning. The immediate gratification you will get when you will have your physical smart card attached to your system if you will know how to deal with that. Okay, let me check to my virtual smart card. I hope it needs to finish. Oops. Okay, something went wrong. And we will not go with help desk this time around. So what we will do, let me show you the second, again, virtual smart card that I have. Okay. I'm sorry, my demo is absolutely interesting. Let me, for a moment, to ensure that I'm on the right thing. And let me go one more time. And if it will not work, I apologize for that. So the whole idea is a demo. Let me walk you through. When you go to WAN UI, and you would be able to actually access our corp through VPN, all what you would need to do is type your PIN in this WAN UI, and I will be authorized to go and do what I need to do with my corporation. Sorry for demo. Sometimes demos don't cooperate very well. But it's really what will happen in this particular case. Okay, I am coming to the end of my presentation, and I want to sum it up for you. And I think you will see that we're all talking about passwords. So we feel that passwords are definitely not safe for our users anymore. And with Windows 8.1, we offer some solutions for this very painful problem. We believe that we need to ensure that users would be able to use very convenient but strong user credentials. And it needs to be rooted in hardware. It needs to be based on asymmetrical keys, asymmetrical secrets. And it also needs to be minimum two-factor authentication, or multi-factor oath, if you like. So it's all what I have for you. And thank you so much. If you have any questions, it's time to ask. And thank you so much for being so great audience. I really enjoy. Okay, go. Any questions? I love questions. Please, yes. Very good question. So with biometrics, we had a very specific goal in mind, that we never ever will store biometrics data in AD or anywhere else. Biometrics data, the templates that we create, will be stored only on your local devices. And the reason is privacy. The problem with biometric, and I'm sure who understand it will appreciate it very much, it's not revocable credentials. With your passwords, you can revoke them. With bio, you cannot. It's you, and you have only 10 proofs. Again, you can use your feet if you like, but again, the point is you have very limited number of proofs that you can go with. And to protect your privacy, we strongly believe, and I'm a strong believer in that you have to have it stored on your device and never ever share with any centralized authority.
So if it's stored on the device, what is sent to AD to authenticate?
Perfect. We have two options. The first, it can be your domain password. But the second feature that I didn't mention here, we have APIs that allow you to associate your BioTouch with certificates and keys. So we called it BioKey, and the idea you can authenticate with your certs by tapping. In my scenario, in my presentations, I used password, my domain account password. But it can be as long as needed because I don't need to remember them. We have event that notify us when password is changed. It's called password notification. And based on this notification, we will prompt user to type a new password and associate the template with the password. Still, template never leave the local machine. Yeah, please. Cred locker.
Yeah, that it's somehow or something goes wrong with the system, you've got to be able to get the recovery key to prove you're you. Is there a second recovery key to handle problems?
Very good question. So I think the question is, I don't know if all of you heard, if something will go with my bio authentication, what do I do? Do we have any recovery mechanism? Today, we're falling back to passwords or, again, clear certs with what we called protectors. And on Cert Vault, we have ability to add protectors to those certificates. One of them will be bio, one of them PIN. So if we're talking about certificates, you can associate PIN and bio to those certificates. And it will be your recovery mode in case bio would not be present, or again, something happened with your fingers and you would not be able to authenticate. However, even if something will happen with your fingers, you always can add additional finger to your account and you would be able to authenticate using this additional finger. Any more questions? Yes, please. So Windows 8.1 on client and Windows 8.1 on NDAS or server. Absolutely, all SKUs. Again, we're part of Windows Core. Whatever we create is actually for every single Windows client and Windows product in general. It's huge responsibility, but really fun to work on that. Okay, so any other questions? Yes, please. I cannot comment on Windows Phone deliverables, sorry. I have my product marketing watching me very seriously. Okay. Any other questions? Anything that, do you see that it would be usable in your places? Are you using certificates? Yeah, that's what we hoped. So thank you so much. If no questions, but thank you so much. You're a great audience. Really appreciate.